So my plan for today is just go through the basic graphs for the class, like 17 graphs that we learned in the class. But hopefully by doing that, we can just review a bunch of different things that we learned. And there's a part of the test that has graphs, so 1/4 of the final will be draw some graphs. But it will also relate to some of the other problems that will have terminology. So the way this exam works is there's a section on terms, terminology. I'm going to post a sheet I haven't posted yet with like a list of terms. So there's a terminology, like define. There's graphs, like draw these graphs according to a couple specifications. There's problems, like a math problem, like problem set problem. And then there'll be another like work through word problem, word problem, explain the answer using the terms that we have. So like a thinking type of problem. So today we'll cover what's related to graphs, but it will also be related to everything. So starting supply and demand for the class. So everybody has seen this before this class, but it sort of relates to a lot of the things that happen in later chapters, so getting to know it well earlier. We have demand curve going down. The lower the price, the more we're going to demand. And we have a supply curve going up. The higher the price, the more they're going to supply, right? And we just want to be able to think about that intuitively. We want to think about each of these curves as they're not just a curve, they're not just a straight line that we draw. They correspond to a set of prices and quantities, right? So each one of these is made up of sets of prices and quantities. At this price, this many would be supplied. At this price, this many would be supplied. We draw them as nice, smooth, straight lines, but they could be totally clumpy. They could be, they could disappear at different points. They don't know. We have a bunch of reasons that mathematically we want them to be continuous and have certain properties, but we don't really need to think about this class. We just think about they correspond to a whole bunch of quantity and price sets. So let's think behind the lines, there's prices and quantities. The second is that there's some equilibrium point. So we get through this all the way throughout the class. Like this equilibrium point is where we're mostly going to think about it in terms of quantity to begin with. A quantity supplied is equal to a quantity demanded at the same price. And this will give us our equilibrium price and quantity. Right? The equilibrium is a solution to people deciding how much to consume and how much to produce at different prices. It's some place where there's no surplus or shortage, right? We could have other quantities at which, a quantity that's too high, but they wouldn't want to supply that this much at this low price. We can think about other places if our quantity was too low. If our quantity was too low, people would be willing to pay much higher than the price that it cost. And so because of the higher price, people would want to produce more. I can't put my finger on there. People would start moving up the supply curve, and as those greater quantities came in, we would iterate towards equilibrium. So we could think about any point that we're off the equilibrium as there would be forces that would be taking us towards the equilibrium. If we had a shortage or a surplus, we would have forces leading us back towards the equilibrium. Another really big part of the supply and demand curve is our starting point for our welfare, which I'll get to a little bit later. But we have these consumer surplus and producer surplus sort of embedded in the supply and demand curve. And I'll do a separate one on welfare specifically. But we know when we have a supply and demand curve, we have some welfare triangles implied by it. We also want to think about shifts of the demand or supply curve versus movements along it, right? So if our supply curve is fixed, but now there's something that's caused a technical innovation and there's a lower cost to produce things, we could have a shift down in a supply curve. If we have tried to tax pollution or ask for some sort of abatement, there could be a shift up in a supply curve. We could have different supply curves shifting up or down. Similarly, this could happen in demand curves. So sometimes we're looking at solutions, we're looking at how to get to equilibrium, and some points we're looking at the whole curve shifting, like all of the price and quantities along a curve shifting, or we can think we're still on the same supply curve, we're just shifting along a given supply curve. So when we're answering questions, we have to think, is the supply curve itself shifting, or are we moving along a supply curve that we have? When we think about that, there's a whole bunch of things that change in this class from our standard model. So we stay where we draw this standard model, and throughout the class, a whole bunch of different things happen to the standard model. One is taxes, so we should always be able to do taxes. And I'll get to this on the welfare one, but taxes, if it's a tax on output, we think of, we have a new after-tax demand curve. If we have like a restriction, like restrict a quantity, they have to reduce their pollution by a certain amount. There's only a certain amount that we can consume of a renewable resource in this period. Different things that restrict quantities. Or changes in other, cost changes. So are there something happening to cost curves outside of this? Like we've changed the cost by putting a price on pollution. How would this change the supply curve in this diagram if we change costs for the firm in another curve? So there's a whole bunch of different things we can do throughout the class, and then look at shifts in supply and demand, how quantities and prices would change, and how welfare would change. So how do we get to a demand curve? We got to the demand curve from indifference curves. Indifference curves start out with the concept of utility. Consumers have utility. Their utility increases as they consume more of a good. And we have utility constant along an indifference curve. So indifference curves, by definition, are something where utility is constant, where we get similar utility with different amounts. And the other big concept that we have in these is bundles. Right? Everything around here is a mapping of two different goods. It's got good 1 and good 2 in quantities of these two. So we don't have price up here. We're just mapping between two goods. We're mapping of how much we want in a bundle of each of two goods. So in difference curves, we have a few properties that are concave or moon-shaped. Usually you don't want all of one good or all of another good, so they'll slope away from the axes on the sides. They're nested, they don't cross. This is a higher level of utility, this is a lower level of utility as you move out from the origin. So we had just a general concept, and so it was hard for some people in the problem set, or also I think it was on the midterm where you got points and you had to draw indifference curves through the points. In these cases, you're just sort of making up the indifference curve that passes through those points but has these properties. Like you have a moon, I gave you a bundle and you had to draw a line that passed through those points that had this moon-shaped slope away from the axis properties. All right, then we have what's called the budget constraint. This has price and quantities and dollars in it. Again, remember, indifference curve doesn't have dollars or income in it. Budget constraint is how we get money involved. So a general equation would be something about the total amount of money that you have. We'll say income equals to price of good 1 times the quantity that you consume of good 1 plus the price of good 2 times the quantity you consume of good 2. So we think about this. We did coffee and donuts, and you walk into the cafe and you have a certain amount of money in your pocket, and you can choose between ounces of coffee and numbers of donuts and pick a bundle. We think about the indifference curve as if you spent all your money on good 1, you'd be over here. This is if you purchase just good 1, and it's going to go, say we're going to make it go through this bundle here. This is if you spent all your money on good 2. So the budget constraint is a map of what you can afford. All of the different bundles that you can afford, given your constraint of the amount of income, the amount of money you have in your pocket at the cafe, or your total income, depending on what problem you're looking at. So sort of by definition, the way we set this up, the highest utility you can get to is the bundle that's just tangent to this indifference curve. We would think about that. The ratio at which we traded off utility between the different goods is tangent to the price line. That's the price ratio of the two goods. So again, when we're doing these maps, we have these intercepts where we buy all of one good or all of another good. We put all our money into just buying X1, we would be able to do that intercept. Some of these times we can't, I could give you, a price and graph it, and you would need to tell me, what my total income was. You can read from the budget constraint, you can read prices out of it. You can read the price ratio out of it. You can read where the intercepts are out of it. And then finally, we have how to get a demand curve out of this, whereas if we had the price of good 2 go up, so the amount of good 1 we can afford is the same, but now we can afford less of good 2. And then the price of good 2 goes up a little bit more. Well, that's not working because this line is going to have to sneak. It still has to be tangent. So I know this indifference curve has to be like this, and it has to be tangent here. Can't cross. It's getting a little messy. So this is where we can go and make a demand curve from these bundles, from these 3 points and what they told us. And here is the price of good 2 and the quantity of good 2. So here was a low price. So this point was corresponding here. Here was a low price and a higher quantity of good 2. Here's the price going up, and we'll consume a little less of good 2. And this third point would go up here, a higher price, and we would consume a little bit less of good 2. So from the indifference curves and the bundles, we get a demand curve out of that, which says as the price of good 2 goes up, the quantity consumed of good 2 goes down. Right? It's telling the same story, and it needs to be consistent between the two graphs. The indifference curve is about utility and just choosing bundles, whereas the demand curve is about price and choosing quantities. But we have a fundamental model behind it of utility that's going to justify the price and quantity in demand curves. That's good for that one. Okay, so then we get back to this welfare analysis. So we'll go back to our demand curve once more. We have a demand curve. We have a supply curve. Now, we also want to think about the areas under these curves and what they represent. So the first is willingness to pay. So the willingness to pay is going to be the sum of adding rectangles under this demand curve. So the first person is willing to pay this much for the first unit. The second person is willing to pay that much for the second unit. The third person is willing to pay up here for the third unit. So our total willingness to pay is this area underneath the demand curve, right? We get to the equilibrium point. The next person, they're not willing to pay at the equilibrium price, so they don't actually buy it. This is how much actually gets purchased at the equilibrium. So say that we have all this willingness to pay represented as the area under the demand curve, and then we have equilibrium price and quantity. Right? So we have so the last person at the margin is paying exactly the price that they're willing to pay for the quantity that they're willing to pay. But all the people before that who had higher demand than that, there's a surplus there. Like this first person only had to pay a price down here, but their willingness to pay was up here. The second person only had a price down here, and their willingness to pay was up here. There's a whole bunch of surplus from all the people that only have to pay this mark with the equilibrium price, but actually valued it a whole bunch more. So that's consumer surplus. Graphically, or thinking about what it is as an area under a curve. I just want to assert that a similar thing is going on with the cost curves. So the supply curves are going to equal the area under it's going to equal the variable costs. It's a similar thing. We can look through this more when we look at cost, but to produce the first unit, it's going to cost them this much. To produce the second unit, it's going to cost them this much. To produce the third unit, it's going to cost them this much. Because we said in the cost that the supply curve is the marginal cost curve for a firm or for who's supplying it. So at any given price equals marginal cost, that's how much they'll supply. But if we think of the volume under this curve, it's like a sum of the marginal cost to produce each additional unit. So if we add up all these rectangles under this curve, this is the producer surplus, is equal to the sum of the variable costs. We're adding up the cost to do that. So for the first unit they sold, they were able to sell it way up at this price, even though that their price to produce it was a lot less. So we could call this profit, but we also call it producer surplus, just because we don't know whether it's going to service fixed costs or to profit. But that's going to sum up at the last unit that they sell, their price is going to equal the variable cost of supplying that unit. But there's going to be a whole area in here called producer surplus. Sorry, producer surplus in here. This part is variable cost. Sorry about that. So producer surplus is all that they get from the market price above the cost that it costs to supply something. All right. Well, this is the straightforward part. Oop, my demand curve just went away. Clean this up. All right. We're going to get this demand curve back, make it go through equilibrium, willingness to pay. And then we're going to say, what about putting a tax on the output of this good, a specific tax per unit of output? So the way we do this in Econ 1 is we say the tax shifts the demand curve down. And we would say there's an after-tax demand curve. The amount that it shifts down, the height of this, is the tax, per unit tax, dollars per unit. The way we think about this is that the consumers are going to stay on their demand curve, how much they're willing to pay for each unit, but the producers are going to see less of that money. The consumers are going to stay along their demand curve, but for everything that they pay, a certain amount of money is going to go to the government, and the rest is going to be available to pay for it in terms of supply. So this after-tax demand curve has a new place that it crosses the supply curve. So at the lower rate that they're now getting, after tax, at the lower rate that the producer's getting, they're going to be willing to supply less. So here's our previous equilibrium. Now there's a lower equilibrium where they've less is being consumed, less is being sold, and then we would take this quantity and put it up to the demand curve that the consumers are still on. So now we have a whole bunch of boxes and triangles to work on. There's one here. Anybody, what's this one called? Deadweight loss. I'm going to abbreviate it. Deadweight loss. So that's surplus, that's lost to both people, both sides, as part of the restriction. And then consumer surplus is going to be decreased by a rectangle, and producer surplus is going to be decreased by a rectangle. Okay, so this rectangle is loss in consumer surplus. This rectangle is loss in producer surplus. Here's the new producer surplus. Here's the new consumer surplus. So some welfare loss goes to each the producer and the consumer. Who bears what depends on elasticities of supply, elasticities of demand, market power, how prices are transmitted, a whole bunch of things. But we need to be able to measure these. You know, I could easily give you these points, and you could have to come up with these areas and explain them. So there's deadweight loss. We good with that one? So the deadweight loss is like this is all part of consumer surplus loss, sure. Yeah, depends how I ask the question. You know what I mean? It's also the other part that I've dropped out is that this whole chunk is that goes to the government, right? This is the amount of tax times the quantity. So this this whole rectangle is tax times quantity at the new tax level, and of this tax burden, we would say that some of it is the change in consumer surplus, some of that is the change in producer surplus. Because consumers are still willing to pay. Their willingness to pay schedule at different prices and different quantities is the same. So the suppliers have chosen to produce at this lower level because they're seeing less. They're getting less income for any unit. Consumers pay amount, the government takes some out, and the producers get an after-tax amount that's less. So they're supplying less. All right, so now we go to cost curves, isoquant, isocosts. This is a parallel to what we've already done with demand. We think of them as bundles to produce output Q, bundles of inputs. So isoquant is done in an input space, both in quantities of inputs. Right? We have two different inputs in production. What it goes through in the textbook is it takes water and nitrogen to make lettuce and salinas. The classic one is it takes capital and labor, it takes machinery and people running the machinery to run a factory. That's the classic Econ 1. Within that, so we similarly have a much similar curve. So this is a single level of output. Here's a lower level of output, has less of both types of bundles. You don't want to have all one sort of input or all the other sort of inputs. It curves away from the axes again. There is, the slope of this is something called marginal rate of technical substitution that we just need to think about as terms of we can replace some of input 1 with some of input 2 and move along this curve. How much can we replace input 1 and input 2 and stay along the same output line? So this is isoquant, the same level of production. Isoquant